Hey, good morning, and how are we doing, everybody? Today, what we're going to do is we're going to take a look at one-step equations with fractions and how to solve and check our answers. So, the first thing that we're looking for with one-step equations is we're looking to actually find whether we want to get our variable alone or get our variable to be 1. Those are the two questions that we always need to identify first. So, given this first equation that we see up here, what my kids know how to do is ask themselves a question: do I have one n? Do I have n alone? In this case, we already know that this is a 1n right here. So that eliminates two choices for us. That eliminates we are not going to be multiplying and we are not going to be dividing. Therefore, the other question that they always say is, well, is n alone? And in this case, no, n is not alone because it has this negative 8/9 on that same side. So we have to actually take a look at that and figure out how to move that from one side, this left-hand side, to the other. Now, in doing that, that would mean that this equal sign is the middle of our balance. So what we're going to do to move negative 8/9 is we need to make it 0. And in order to make a negative 8/9 0, that means we have to add 8/9 to that left-hand side. On the other side then, what we do to one side, we must do equally to the other side, which means we're going to add 8/9 to the right-hand side over here. And what my kids got a good handle of doing is we take a look at negative 8/9 plus 8/9 is 0. So we cross that out right away, and we just drop down this n. So this n's just going to come down here. And I could put plus 0 if I really wanted to, but we always say, well, what's the point of actually doing that? Well, there is none because we already know 0 plus n is, in fact, n. Now, furthermore, we're going to take a look at this 4/9, and we're adding it to 8/9. And now it's just a simple fraction problem in which we look at it and say, hey, you know what? Do we have a common denominator to add these fractions? We do. In this case, we already know our final answer is going to have a 9 in its denominator. And then from there, 4 plus 8 is 12. Lastly, to finish this one up, especially with fractions, we need to make sure that we reduce this fraction. So when we reduce this fraction, I notice that 12 and 9 share a common denominator of 3. When I reduce that fraction by 3, that gives me 12 divided by 3 is 4. 9 divided by 3 is 3. And that is my final answer. Pretty simple with solving fractions in this case. So, now we're going to move on to the next example. Next example for us, ladies and gentlemen, now we're going to actually take a look at what happens with a fraction. We already solved one where there's adding and subtracting with a fraction, but what happens if this is actually multiplying and dividing with a fraction? My classes know what to do when we actually are multiplying a fraction times a variable. And in this case, now it's not a question of do we have y alone, because it actually is alone. The problem is this negative 11/14 makes it not a 1y, which that's what we need to get then. So in order to get that 1y, we need to multiply both sides by the reciprocal of negative 11/14. I know my guys would say, hey, keep change flipped. So we are going to keep this negative 11/14 the same. We're going to change that to a multiplication, and then we are going to flip it as 14 over negative 11. On the other side, we do what we do to one side, we're going to do exactly to the other. So I'm going to write 14 over negative 11. And now, the last thing I must do is place this 1 underneath 22, because I can make any whole number of fraction by putting it over 1. From here is the fun stuff that I actually like. I actually like cross-reducing, and I find what common factors I have in a diagonal pattern with these fractions. Well, 14 and 14, they divide and they get you 1. Negative 11 divided by negative 11 is also 1. So the goal was to get 1y, and we did. On the right-hand side, I find, well, I can't find a common factor between 1 and 14, but what I can find a common factor between is 22 and negative 11. Common factor of negative 11. So negative 11 divided by negative 11 is 1. Negative 22 divided by negative 11 is negative 2. And now it's a simple integer problem of negative 2 times this positive 14, which we know is negative 28. This is our last fraction problem. Our last fraction problem is, again, another adding and subtracting one, but this one is unique in the fact that in looking ahead, I notice I do not have common denominators. When we were multiplying and dividing up in the second problem that we started with, we did not need a common denominator. Why? Because we can actually cross-reduce those fractions. That's multiplication and division. The unfortunate thing here is we have to look at a common denominator and find that. So that's not the biggest deal in the world, so we're just going to take care of that very simply. In order to get b in this case, it already is 1b, so we're not multiplying or dividing, but we are adding and subtracting because b is not alone. We have to get rid of this 6/5. Here's how we do that. What we have to do to get rid of that positive 6/5 is we have to make that, again, 0 by subtracting 6/5. And what we do to one side of our equation, we do to the other side in the exact same fashion. From there, I know that 6/5 minus 6/5 is 0, so I did get my b alone. And now it's just an integer, or not an integer question, it is a real number question of 7/9 subtract 6/5. Now, I cannot subtract them right off the bat because these denominators are not the same. They're not like denominators. So what I have to do is make sure that I get a like denominator down here. And to do that, I'm going to find the least common multiple between 9 and 5, which off the top of my head I know is 45. Now, how do I get that? I'm going to multiply the 6/5. The denominator gets multiplied by 9, which means if I want to keep this as a 6/5, I have to multiply the numerator by 9. Because we know that 9 over 9 is 1, and anything times 1 is still the number itself. On the other side then, I have to multiply again, but I have to multiply the 9 by 5, because I want to get that 45, but in order for me to keep this as 7/9, I have to multiply my numerator by 5. Because we know that 5 over 5 is also 1. Now from here, I don't see any cross-reducing like I did in the previous problem, so what I'm going to do is just multiply straight across. So I take 5 times 7 is 35. 5 times 9 is 45. So that is still, if I wanted to reduce this, that would take me back to 7/9. I take 6 times 9, which is, not 63, 54, over, and then 5 times 9 is 45. And if we notice, this is the exact same, these are the exact same fractions, but the only difference is this time now they are actually with a common denominator. And I always tell my students, you know what? We know what our denominator is going to be in this case, so write it in right away as that 45. And then let's actually subtract 35 minus 54. And we already know right away that our answer is going to be a negative because this 54 is greater. And now it's just a question of what is 54 subtract 35. So I could pull them over to the side and some of them will actually write it out, which is fine. I encourage them to do that, especially when not using a calculator. So 14 minus 5 is 9. 4 minus 3 is 1. So this is a negative 19 over 45. Therefore, B equals negative 19 over 45.